Привет, guys. This video, we're just going to be going over the rules of differentiation. So the product rule, the quotient rule, and the chain rule. These are like the main things you're going to be using in this course when you're taking derivatives, and these are really important to be able to recognize when to use them. So at the beginning of the video, I'll just go over what they are, but I'm gonna give like some tips on this because in the classes, lots of times these are gonna be nested problems. So you're gonna have a chain rule problem inside of a product rule, or a product rule inside of a quotient rule, and sometimes people get really tripped up and confused about it. So yeah, so this video I'm just going to outline what these rules are, how you use them, and some good ways to yeah, to work through like the ugly nested problems. So right now we're just going to start with the product rule. So the product rule is when we're taking the derivative, when we have some function, let's call it h of x, and it looks like, or it's of the form of two functions being multiplied by each other. So it's a product. So it looks like f of x times g of x. And so what the product rule is when we take this derivative, that this is going to be, you take the derivative of the first one and you multiply it by the second one. And then you add the first one untouched multiplied by the derivative of the second one. And that's it. And so let's look through an example of that. So let's say we have a function that looks like we want to take the derivative, d by dx, of e to the x times x squared. So in our last video, we talked about like what the derivatives are of the elementary functions. So we know the derivative of e to the x is just e to the x. So when we do this one, take the derivative of the first one, e to the x. So that's just itself untouched. We multiply it by the second one, x squared. And then we're adding the first one untouched, which is still just e to the x, and then times the derivative of the second one. So what was that derivative of x squared? It was 2x. And that's it. And then so we can just factor the e to the x out here if we want to just simplify it into its like most easy form. So it's gonna be x squared plus 2 to the x. Yeah, and so if we look at another example, let's say we have d by dx of 2x cubed times sine x. So again, same thing. We're going to take the derivative of the first one. So remember that derivative moves through the constant, and it's going to be 6x squared, because that's the derivative of 2x cubed. This is our f right here. This is our f of x. And so this is our f prime of x. And so what would our g of x be? It would be whatever that thing's being multiplied by. So this is our g of x. And so we're going to have it untouched, so sine x. And then plus, we're going to have our original f of x, that 2x cubed multiplied by our derivative of that second function. So times cosine x, because this is our g prime x right here, right? So this is the idea that we're doing with the product rule, is we're just recognizing we have some function multiplied by another function, and so we're taking the derivative of that first one, multiplying it by the second one, and then we're adding the first one untouched multiplied by the derivative of the second one. That's the basic idea here. Uh, yeah, so just recognizing, and if it helps you, you can label them. You can look and see, okay, I'm gonna label this one F, I'm gonna label this one G. What's the derivative of F? What's the derivative of G? Sometimes that helps people. Sometimes that actually makes it more complicated. So just do what works best for you, but just keep in mind that all you're doing here is you're just seeing that you have the product of two functions. Take the derivative of the first one, multiply by the second one, and then add the derivative of the second one times the first one. That's the product rule. The quotient rule is going to be looking somewhat similar. So that's when we have some function divided by another function. We want to take the derivative of that. Well, that's going to equal the derivative of the first one multiplied by the bottom function, subtract the top function times the derivative of the bottom function. And all of this is going to be over that bottom function squared. So the main idea that you're doing here with the quotient rule is look at this form. This form looks really similar to, like, the top of the quotient rule looks really similar to the product rule. The only difference is when we take the derivative of that bottom, we get that negative sign. And that kind of makes sense, right? Because the bottom is to the exponent -1. So if that helps you think of it, that's one way. And then that denominator is just getting squared. So that's the idea that we have with the quotient rule. So let's work through some examples of that. So what's the derivative, d by dx, of let's say x squared divided by x minus 3. So what are we gonna do? We're gonna follow this. We're gonna recognize that this right here is our top. This is our numerator function. This is our f of x. And this one down here is our denominator function. This is our g of x. So we get the derivative of the top. So that would be 2x. That's our f prime. Multiplied by our g of x. So x minus 3. And then we're subtracting off the top function times the derivative of the bottom function. So what's the derivative here? So the derivative of x is going to be 1, and the derivative of that minus 3 is going to be 0, right? We talked about that last episode. So that's just going to be 1. And all of this is going to be over that bottom squared, over x minus 3 squared. And then the last step, so usually after you do these rules in class on tests or assignments, you're expected to simplify it further. So this one we can simplify a bit. We'll expand, we'll distribute this through that bracket. So we'll get 2x squared minus 6x, and then we have minus x squared. So that minus x squared is going to cancel out with one of those 2x squareds from the top, and then we have x minus 3 squared. And then if we want, we can now factor out that an x off of the top, because that's common to both terms. X. So that would be our most like simplified form of that is you first expand everything out, see what cancels out, and then refactor it. But yeah, this is the idea with the quotient rule again. So this one's easy to recognize when like where this falls in the equation. So it's just if you are taking the derivative of some function and the entire thing is a fraction, then you're going to use quotient rule. If a fraction is appearing somewhere in it, you can use quotient rule. Um, I find that sometimes because you don't need to use quotient rule. Once you use once you know chain rule, which I'm going to get to next, you can combine chain rule with product rule in order to like solve for quotients. However, I find that sometimes that can make things like more complicated, and that's to some students like you're making a lot more extra steps for yourself, um, so when you see a quotient, like just use quotient rule, like it's easy, like it's easier to use than trying to rederive everything yourself and just making like so much work for yourself. That's one tip that I'll give.